So we're going to continue our study of trigonometry, continuing with some of the trig that you learned last year in geometry. And we are on page 5 of the notes. Before we get into this, there's some notation that we need to talk about. When we're dealing with labeling parts of a triangle, we're going to label the angles with capital letters. We're going to label the angles with capital letters. So I'm going to make this capital A, I'll make this capital B, I'll make that capital C. To label the sides, we're going to label them using lowercase letters, and we're going to match up the sides and the angles by labeling the side directly across from an angle with the same letter, just lowercase. We are going to label the side directly across from an angle using the same letter, but lowercase. So directly across from A is this side over here. I'm going to label that little a. Directly across from B is this side. I'm going to label that little b. And directly across from C is that side. I'm going to call that little c. We're going to see this notation as we kind of keep moving through this unit. The next thing we need to look at, we're going to call solving right triangles. And to solve a right triangle, we basically need to find all the sides and all the angles of the triangle. Find all angles and sides of the triangle. We're going to do this using what we know about trig and also making use of the trig features of your calculator. First thing I'm going to do though, I think the easiest thing for me to first figure out is this missing angle over here. You know that all the angles in a triangle add to 180. So if I just do 180 minus 90 minus 57, it's going to give me 33 degrees, and I can label this angle over here as 33 degrees. And you know what, I'm going to put some letters on these things just so I can talk about stuff over here. By the time I'm done, I want to know what each of the angles will be. Actually, I already know all those angles. Angle A is 57 degrees, angle B is 33 degrees, and angle C is 90 degrees. And I also want to know what each of these sides will be. I'm going to label this little a, this is little b, this is little c. And I already know what little b is. Little b is just 7. Next, we need to try to find little a and little c. And trigonometry is going to help us get there. For example, if I want to find little a, let's ignore little c for right now. I want to use one of the angles. You know, why don't I use the 57 because that was the one given. I want to use the side that I'm looking for, which if I'm dealing with 57, this side would be my opposite. And I also want to use the side that I was given. I was given 7, which is my adjacent. So I want to make use of 57, the opposite, and the adjacent. Well, what trig function uses opposite and adjacent? That's the tangent. I'm going to write out a little equation that says the tangent of 57 degrees equals the opposite, little a, over the adjacent, which is 7. And I have an equation to solve. How do we solve this? Well, we need to go to the calculator. First thing you need to do on your calculator is make sure your calculator is set in in degree mode. There are two different modes of your calculator, degree mode and radian mode. There are two ways to measure angles. You only know about degrees so far. Radians, well, we're going to hold off on that till the second section. On your calculator, you can push the mode button, And then I'm going to go down to over here. It says radian or degree. I'm going to select degree and push enter. And you should have something very similar on the scientific calculator. Maybe a button that says DRG or something like that, degrees, radians, and gradians. And if you push that, it'll change the setting on the home screen. If you're not sure how to do this, look this up online, type in your calculator brand, and type in how to change to degree mode, and you'll see how to do that. To make sure your calculator's in the right mode, one little test we can do is we can type in the sine of 30 degrees, and if it's working properly, it should tell us 0.5. Let me check my calculator. Am I in the right mode? Sine 30 equals 0.5. Perfect. Why is the sine of 30 degrees 0.5? Not yet. We'll get there in a couple days, actually in a couple weeks. But now that we have that, I'm going to, try to solve this little equation for A. I'm first going to try to do some algebra before I go to my calculator. How do I get rid of a divide by 7? Well, that's easy enough. I'm just going to go and multiply both sides over here by 7. And I'm going to get A equals 7 times the tangent of 57 degrees. At this point, I'm just going to go to my calculator, and I'm going to type that in. I'm going to type in 7. It's a little tough for you to see, but I'm assuming you know how to type things in the calculator. 7, tan. I'm going to find that tan button. All three trig functions should be in a row, sine, cosine, tangent. I'm going to use tan. 57, and I'm going to get a decimal. My directions say to round to the nearest thousandth. So 10.77905 to the nearest thousandth would be 10.779. And that's how long this side over here is going to be. 10.779. I'll put that in over here. 10.779. Then I just need to find the hypotenuse. I could use the Pythagorean theorem, but I would rather not use that because I'd have to use this rounded decimal. And if I'm using an answer that I've already rounded and try to find the final answer, it might be off more than I want it to be off. Rather than using Pythagorean theorem, I'm going to go back and I'm going to use trig again. This time, I want to use the 7 and the C. I have a choice of either using 57 degrees or 33 degrees. I don't know, let me stick with the 57. If I'm using that angle, and the 7 and the C, I have my adjacent. I want to know my hypotenuse. Well, what uses adjacent and hypotenuse? Cosine. I'm going to write out a little equation here. The cosine of 57 equals the adjacent, which is 7, over the hypotenuse, which is C. Okay, this is a little more involved to solve. But to get rid of the divide by C, I'm going to go and multiply both sides by C. By the way, make sure in the homework you're showing your algebra. It gives me C times the cosine of 57 degrees equals 7. I'm going to go and divide. And I'm going to get C equals 7 over the cosine of 57 degrees. I'm going to go to my calculator. I'm going to type that in, 7 divided by the cosine of 57 degrees. I'm going to round to the nearest thousandth. That's going to give me 12.8525. That 5 will round up the 2 to a 3, so 12.853. And I've now found all the sides and all the angles of my triangle. Now, there's more than one way to do this. I said the cosine of 57 equals 7 over C. Well, I could have used 33. And if I use 33, my 7 would be the opposite. My C would be the hypotenuse. I would use the sine of 33 degrees equals the opposite, 7 over the hypotenuse C. The work would look different, but you'd still end up with the same number. Let's take a look at 2 more of these. In letter A, solve the right triangles and round when necessary. Well, first thing I'm going to do is I'm going to draw this thing out. Angle A is 32 degrees, so I'm going to say that's A, that's 32 degrees. Angle C is 90, so that one's going to be my 90. The other one's angle B, and I know that little c, which has got to be what's across from the hypotenuse, across from the right angle, the hypotenuse is going to be 8. So there I go. And I need to go try to find some things here. I'm going to label this little a, label that little b. So I'm going to go and I'm going to find little a. Little a is my opposite of angle 32 degrees. And 8 is my hypotenuse. What uses opposite and hypotenuse? Well, sine. I'm going to write out the sine of 32 degrees equals the opposite of a over the hypotenuse of 8. Go through some algebra here, times 8 times 8. I'm going to get a equals 8 sine 32 degrees. Go to calculator, 8 sine 32 degrees. That should give you about 4.239 for little a. 4.329. To find little b, well, little b is the adjacent to 32 degrees, and I have the hypotenuse of 8, so I can say the cosine of 32 degrees equals little b over 8. Again, I'm going to go and multiply both sides by 8. B is going to equal 8 times the cosine of 32 degrees. Go to the calculator for that. 8 times the cosine of 32 degrees. 6.784. Oh, and actually, I forgot to do the easiest part. I forgot to find the missing angle. Well, 180 minus 90 is 90. Minus 32 is going to give you 58 degrees. So I know capital A is 32 degrees. I know capital B is 58 degrees. And capital C is 90 degrees. Little a, then, I found to be 4.329. Little b, I found to be 6.784. Little c is 8. One more of these. Letter B, I'm going to draw up my triangle. Let's see. So this time they're telling you that the right angle is capital B, so I'll label that as B. C is 74. I guess I'll put C up here. I'll call that 74 degrees. Here's capital A, and I know what's across from A is 6. Hypotenuse is little b. Adjacent is little c. I'm going to, I don't know. Why don't I find my little c first? Little c is the opposite of 74, and 6 is the adjacent to 74 degrees, so that sounds like a tangent. I'm going to say that the tangent of 74 degrees equals the opposite of c over the adjacent of 6. Easy enough to solve. Times 6 times 6. Little c is going to equal 6 times the tangent of 74 degrees. Go to your calculator. That should be about 20.924 for the length of that side. So now we just need to find letter B. Well, if I'm going to use 74, 6, and B, 6 is my adjacent, B is my hypotenuse, so that sounds like cosine to me. And I can say that the cosine of 74 degrees, just make sure this is on here. Yep, cosine of 74 degrees equals my adjacent is 6, my hypotenuse is B. This is one where I'm going to have to go through a little bit of algebra here. I'm going to multiply both sides by B. It's going to give me B cosine 74 degrees equals 6. I'll go and do some division. So letter B equals 6 over the cosine of 74 degrees. Go to your calculator. 6 over the cosine of 74 degrees. I think that should be about 21. 0.7677 means that's going to round to an 8. Oh, then again, I still have to figure out the missing angle. Well, 180 minus 90 is 90, minus 74 should give you 16 degrees over there. So capital A is 16 degrees. Capital B is 90 degrees. Capital C is 74 degrees. Little a, I told you was 6. Little b, we found to be 21.768. And little c is about 20.924. One more thing that we need to look at. So we've been solving triangles using trig and using the calculator. There are two special types of triangles that you talked about solving and getting exact answers for last year in geometry. And we need to review those right now. Specifically, 30, 60, 90 triangles and 45, 45, 90 triangles. I'm not going to go through where this came from. You saw this stuff last year. I'm just going to sort of jump straight to the results and see how to use this. In any triangle with two angles of 45 degrees and an angle of 90 degrees, I can call the side opposite 45 degrees x, and the one opposite the other 45 degrees is also x because it has to be an isosceles triangle there. And then what's opposite the hypotenuse is going to be x root 2. You can prove that by using the Pythagorean theorem. We're not going to get into that here though. In a 30, 60, 90 right triangle, I can call what's opposite the 30 x, what's opposite the 60 x root 3, and what's opposite the 90 as 2x. And I can use these ideas to solve some right triangles and to give exact answers rather than using decimals. In the homework, make sure if it says use trig, you're using your sine, cosine, tangent. If it says use the special right triangles, 45, 45, 90, 30, 60, 90, you do what I'm about to show you here. In letter A, we're asked to find the missing sides. Well, I'm going to go and I'm going to label all my sides because I know what's across from 45 is x. And what's across from 90 is x root 2. So I'm going to set up something that looks like this. Well, actually, I know what x is. X is going to be 3. So this side, x root 2, just has to be 3. Root 2. That's it. Let me do the same over here. Across from 30 is x. Across from 60 is x root 3. And across from 90 is 2x. Well, here, I need to do a little bit of equation solving to find x. It's a really easy equation, though. I'm going to say 2x equals 4. I'm going to go and divide both sides by 2. And I'm going to get that x equals 2. So I know this side is 2, and I know this side is 2 root 3. Two more that I need to show you. 45, 45, 90. What's across from 45 is x. What's across from the other 45 is x. What's across from the 90 is x root 2. I've got some equation solving to do here, but it's a little bit more complicated this time. I'm going to say x root 2 equals 5. Well, I'm going to go and divide both sides by root 2. So divide by root 2, divide by root 2. I'm going to get x equals 5 over root 2. But of course, I should rationalize the denominator, so I'm going to multiply by root 2 over root 2 and get 5 root 2 over 2, which means that I know this side is 5 root 2 over 2, and I know this side is 5 root 2 over 2. In this last one, I'm going to label what's across from the 30 as x. What's across from the 60 is x root 3, so it's going to be another equation with some roots in there. What's across from the 90 is 2x. So I'm going to say x root 3 equals 7. I'm going to divide both sides by root 3, divide by root 3, x equals 7 over root 3. Then I'll rationalize my denominator times root 3 over root 3, and I'm going to get 7 root 3 over 3. Which tells me that this side over here is 7 root 3 over 3. And 2 times that, well, that's just going to give me 14 root 3 over 3. Make sure in the homework, if it says to use special right triangles, you are showing work like this. You will not get credit for that part of the homework if you use sines, cosines, and tangents, where I want you using the 30, 60, 90s, and 45, 45, 90.